Good morning. We are going to be going over our Unit 4 Day 2 activity, and that is going to be looking at the difference between linear growth in our classroom and exponential growth in our classroom. And actually, we're going to be using this same activity on our grasp. So we have a really big grasp coming up here. And it's an invention of your app. So you're going to come up with an app idea and you're going to put a slideshow together about it. But we need to ask the question, do I want my invention to grow exponentially, or do I want it to grow linearly? Okay, so that's what this is going to be asking us here in Unit 4 Day 2 activity, linear versus exponential tables. So the first question here is, what is linear growth? So what is the equation of line? You can look at your notes from last class. Please use function formatting. And I've started off for you right here, f of x equals, and then you have a spot to type out your equation. Now, if you don't know, you can always check your notes from the day before. So I put a link in here. Here are the notes. When they load up, we can see that we have linear equations on the top, exponential equations on the bottom. So if I just zoom in here, up here, I can see exactly what a linear equation is going to be. It's going to be f of x equals mx plus b. So that is the answer that I would be putting in right here. Then for question 2, it says, how many friends do you have on social media? This will be your growth value. You will add this number every single day. Linear growth is the slope, or the m. So that means this number right here is going to be the number of friends I have on social media. So I have about, on average, I would say, let's just say 1,500 Facebook friends. And then I have about 500 connections on YouTube. So all in total, I would have 2,000 social media connections. Okay? So you can add up all of yours. You can make up a number, or you could just use my number. But it would be more fun if you used your own. How many students, how many people do we have in class is question 3. This will be your starting value. And of course, in a linear equation, the starting value is the y-intercept, or the b value, which would be right here. All right. So you have, how many people do we have in class? This will be your starting value. So usually most of my classes are around 30. You'll have to answer with the number that's in your class. So I'm just going to say 30 students and teachers. And then I'm seeing a question here that I probably should add, which is, what is the linear equation? Okay, so using this example here, using your answers, what is your plug those values into the linear equation and record it here. Okay, and so that would mean that then I need to have an answer here that has a y, or an f of x, equals mx plus b, where my m is going to be this number of growth, so 2,000, okay, and then my b will be my starting value, so the number of kids in class. There we go. So now we're going to create this table. So on day 0, we start off with our 30 students. Then every day, add your number of social media connections every day. So then our next day would be 2030, right? And then after that, I would have 4030, etc., etc. So you can fill out the rest of this with your numbers. What do you get for this whole first week of growth here? Okay, so finish this one up and join me for the exponential part. All right, so now exponential growth. When we go back to our notes, remember the exponential growth is the bottom part of the notes here. Most of the important information is over on the equation side. So we can see that the one with percent growth is the one we're going to use today. Our exponent is up here. My A is the y-intercept, it's the start, and the R is the percent change. So it asks me straight up, what is your A? What does it mean? Look at your notes from last class. So if I look at my notes from last class, A is the y-intercept. It is the starting value. All right, so you can type that in right here. It is the y-intercept, the starting value. Now, same question as before. How many people are in class today? This will be your starting value. Last time we said it was 30, so this better be the same answer that you had up here for question 3, because it's going to be the starting value for both of our equations. That makes sense. Now, your growth will be 1%. How do you write the equation we are modeling? Plug the numbers into the equation below. Remember, you need to convert 1% into a decimal. So the numbers that we need to change is this B, or this A, and this R. So if I wanted to do 1% as a decimal, I could go ahead and say, all right, I know that 1% as a decimal is, well, I'm not actually really sure. If you're not sure, you can always use your computer, use your resources. You can say, what is 1% as a decimal? Don't let things slow you down. Look at this, 1% right here. 1% is 0.01, okay? And if you wanted to understand this, all you have to do is move your decimal place to the left 2 times. But don't let this slow you down. Like, you can always check your stuff. No excuses. All right, 0.01 is our decimal value. So that's going to go into the R here. So we're going to replace the R with 0.01, and for some reason it got rid of my exponent, so I'm going to add that bit back in. To get my exponent, you have to use Shift and A. That gives you this little caret button right here. Shift and A, it moves it up, or Shift and 6, it moves it up. So here's my X up here, and then I need to start with my starting value, which is going to be the 30. Okay, so here I have my starting value, and I have my percent growth. Now, it says that using Desmos is the easiest way to fill this out. But I know that on times 0, I'm going to start with 30. I know that for a fact. So I'm going to start off with 30. But then let's go ahead and open a Desmos. So here I have Desmos. I'm going to open my graphing calculator. And I'm going to copy this very carefully. And hopefully it pastes in. And look, it pastes in, but it's incorrect. This X is not an exponent. It's not up high. So if I want to change this to an exponent, I can use this button right here to put it up. See how it goes up when I push that button? Or I could just use Shift and 6, and that will put it up as well. Okay, so we have successfully graphed this. We got to zoom out because Here we only have 5, but I start at 30. So we have to zoom out to at least 30, not 20. Oop, right here's 30, so we zoomed out. And here's my nice graph that's curving up, and you can see it's growing, growing, growing. So if you wanted to fill this out, using Desmos is easiest. So all you have to do is g of 0, that's your 0 day. G of 1, it's your first day. G of 2, it's your second day. G of 3, that's your third day. G of 4, and so on and so forth. And you're going to fill these out in the table. Now this seems to be growing very fast or slow. You're going to have to make your own decision. So is this faster or slower than the linear equation? All right. That is this question. Which graph seems to be growing faster? So you're going to have to look at your tables and remember that one is growing by 2,000 each day and the other one is growing like this, from 30 to 30.3 to 30.6 to 30.9 to 31. So you'll have to answer your question, which one is growing faster? And also, which one do you think will reach 1 million users first? All right. Last one. This is the most important part, graphs. Please graph your linear equation and exponential equation in Desmos. Okay. So I'm going to clear off all of these. I already have my exponential equation in here. If I wanted to get my linear equation in, I could just go up to where that is, highlight it, copy it, drop it in right here. And it doesn't work. You see, it gives me this error that says points are written like this, 1, 2. And that's complaining because I have a comma here. So if you get rid of this comma, it'll immediately work. And then right here, we have this blue line that is just shooting straight up. It's really quite ridiculous. So if we wanted to, we can take a picture of this. I use snipping tool. You'll use your screen grab. Take a quick picture. Oops, that was not a good one. Let's take another one so it actually has all the pieces in here. I like to have it where it actually has my equation in the picture. That way I know if I mess things up later when I come to check. So here's my picture of the graph here. Provide a link to your Desmos. Use the share button on the top right. Actually, honestly, I think I'm going to change this question to be the last question because that makes more sense to put it last here. So I'm going to remove it here because I want to have a link to the one with your million. I think that'll be cool for me to be able to check that. Okay, so this one here says using your graph in Desmos, set y equals to 1 million to see which function reaches 1 million users first. So this is going to answer your question, which one goes viral first? So if I set y equals to 1 million, remember, as soon as I put a comma in, it's going to complain. Boom. And it starts complaining. So if I enter 1 million in with commas, it's not going to work. If I remove the commas, then it works for me. All right. We've got to zoom out till we actually see that. Zoom, 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 zoom. Where the heck is 1 million? There it is. Here's our green line, our finish line. And I can't really see much of anything. It's because this is too far zoomed out. If I wanted to set this specifically, I would want my y's to go from 0 to 1 million, but I want my x's to go maybe only 1,000 over or 2,000 over. Like I want to make it zoom in on the x-axis but stay fixed on the y-axis. So right here I can change my x-axis, okay, and I can keep my y-axis. So where I care about the graph is from 0 to maybe 1,000, maybe bigger than 1,000, who knows, 3,000. You'll have to play with this and see which one is better. Now, look here. Okay, now I finally can actually see, and you should be able to answer the question, which one reaches my finish line first? Is it my linear or my exponential? And how many days does it take to reach that finish line? Okay? So that'll help you out. If you want to provide the link to your Desmos, this is the share button right up here. So you click this, click copy, and then you put it in here, put a space, and then it'll be a link, and it goes directly to the Desmos that you created. All right? Good luck.